When selecting tools, the risk for picking the wrong tool for the job exists at the boundaries. Let's consider some common technologies for building web applications today. Each technology has a specific purpose. HTML provides semantic markup for our content. CSS separates our styling from our markup. JavaScript provides behavior, and the server-side language that we choose manages the business logic. Finally, SQL is useful for relational database data access and manipulation. And here's the thing. It's the boundaries and interactions between these technologies that get people in trouble. First, it's tempting to put HTML in a JavaScript string so that you can dynamically inject HTML onto the page, but all markup should ideally be written as HTML. JavaScript is the wrong tool for storing markup. And on the flip side, it's tempting to put JavaScript directly in your HTML, but this mixes concerns by injecting behavior directly into your markup, and it eliminates the opportunity for caching and reuse. When possible, JavaScript belongs in .js files and HTML belongs in .html files. Second, generally relational databases should contain raw normalized data so that it can be leveraged for a variety of purposes. Thus, storing HTML in the database or injecting HTML and query results as strings is problematic. It binds the presentation and data storage together, which makes reuse really difficult. It's a very similar story with the HTML-CSS interaction. It's tempting to place styles inline in HTML, but this mixes our semantic markup with style. These are separate concerns, which eliminates the opportunity for caching and reuse of CSS. It's easy to create highly dynamic SQL in a server-side language like C# using strings to generate SQL statements, but stored procedures and ORMs often provide a safer and more elegant approach to generating dynamic SQL. Finally, this is the most common tool misuse that I see, using a server-side language to generate dynamic JavaScript. In most cases, JavaScript can remain in a JS file, and JSON can be returned from the server to provide dynamism. Let's now take a look at a specific example of using the wrong tool for the job to generate dynamic JavaScript. Here we have an example application that is delivering the Google Analytics JavaScript code dynamically. As you can see, the Google Analytics ID is being injected into the middle of this script. So this is a snippet of code that would sit in C#, for instance, within a code behind. And the idea was that we'd put it within a string so that we could inject the one dynamic piece here, which is the Google Analytics ID. Now let's take a look at a cleaner example. Here we can see that the JavaScript code is now sitting within a file called googleanalytics.js. And we can also notice right away that we have the benefit of code coloring, which makes the code much easier to read. And imagine if I made a typo along the way, I'd know immediately. If I typo up top and type document and miss the U, I wouldn't know this until I ran the code. But my IDE will help me out as I write within a JS file using the style below. Now you're probably wondering, where is this website setup.googleanalytics key defined? Well, it's defined in the header of the document. Here we can see a snippet of JavaScript that defines this data. And the beauty of all this is all just native JavaScript. To inject this dynamic data into the header, you can use your language's JSON serializer to serialize some native object. In this case, I'm using C#, so I can use C#'s JSON serializer to serialize this out into the header so that I get this dynamic piece of data that's useful for my JS file down below. And there's a lot of benefits to doing so. By staying native, our code is cached. It's downloaded once by the browser, and then that JS file isn't requested again because it already has those resources. When you put JS within your HTML, it's downloaded again and again on each page request. It's also code colored. If you looked at the old version in a string, it was all code colored as the one C# string, which makes it very difficult to read and maintain. Closely related to this, you lose syntax checking when you try to write one language within a string. There's no way for it to check whether you've made a typo, so it becomes very difficult to maintain. Separate files for each language are easier to maintain and understand because each file handles a single focused role, and we wouldn't have any easy way to reuse this code. This is also more performant because it avoids string parsing on every single request. Instead, we serve up the file once, and then browsers in a lot of cases don't request it again for a long period of time. Finally, we can minify and obfuscate our JavaScript code in this case because it's a separate file. That wouldn't be easily done if we were doing string parsing and building this together dynamically. Of course, the importance of staying native isn't at all specific to JavaScript. There's a variety of opportunities to find yourself struggling with strings when there's a less painful alternative that involves staying native. The bottom line is, avoid using one language to write another language or format via strings. Creation of these formats dynamically is a solved problem in most popular languages these days, so be sure to leverage libraries to generate such formats. A good rule of thumb is to strive for one language per file. Generating any of these items via strings requires the reader to understand the interactions of two technologies simultaneously. And as we just saw, this totally breaks tooling support. So, if you notice you have two languages in one file, think twice about how you could eliminate one by solving the problem in a different and more elegant way.